Algebra 2 Honors 9.8, an extra worksheet on the unit circle and using it to solve trig equations. So notice this is no calculator. This should all be work without a calculator. And you have an interval given in radians, so your answer should be in radians. So I'm going to do probably about 4 of these, and then you are to do the rest of these and turn them in as your homework. So in number 1, we have the tangent of x is negative root 3. So I want you to show that you are going to identify which quadrants tangent's negative in. Tangent works with y and x, and that's going to end up being negative in quadrants 2 and 4. That's where 1 is positive and 1's negative, so the ratio will be negative. And then you need to think, how do I get ordered pairs where the y over the x becomes root 3? And that's going to be where you have the root 3 over 2 divided by the negative 1/2. That's going to come out to root 3. That's your quadrant 2 angle. And here is your quadrant 4 angle. Then show that the tangent, and use the radian value because we want answers in radians because the interval was in radians. Tangent of 2 pi thirds is the y coordinate over the x coordinate, which is root 3 over 2 over 1/2, negative 1/2, include the signs, and that comes out to negative root 3. So therefore, one of the angles that will have a tangent that is negative root 3 is 2 pi thirds. That's one of your angle answers. Then in quadrant 4, we also have 5 pi thirds. And there the y over x is positive, or negative root 3, over 2, all over a positive 1/2. That also comes out to negative root 3. So therefore the other angle that will give you a tangent that's negative root 3 is 5 pi thirds. So those are your answers. Let's look at number 2. We have secant being 2 root 3 over 3, and it's positive. So the first thing I want to identify is in which quadrants is secant positive? Well, secant's the reciprocal of cosine, which deals with x and r. So it's going to be where x is positive, which is going to be quadrants 1 and 4. Then I need what ordered pair is going to give me 2 root 3 over 3 when I have r over x. So basically it's what x, when I take the reciprocal, will I get 2 root 3 over 3? Well, it's going to be where the x values are root 3 over 2. So there's your quadrant 1, and here is your quadrant 4 angle. So the secant of pi 6 is r over x, which is 1 over root 3 over 2, which is 2 over root 3, which is 2 root 3 over 3. So there's one of the angles whose secant will be 2 root 3 over 3. The other is secant of 11 pi 6. Again, r over x is going to be 1 over the x coordinate of root 3 over 2, which is 2 over root 3, which is 2 root 3 over 3. So both angles pi 6 and 11 pi 6 satisfy this equation, so the answers to this equation are x's pi 6 and 11 pi 6. So x is just the variable being used for the angle. We could have used theta instead. Let's look at number 3. Where sine is 0 is not a 30, 45, or 60 degree angle. It's not a pi 6, pi 4, or pi thirds angle. Where sine is 0 or 1 or negative 1 is a quadrantal angle. And you need to know that. So we are looking at 0, 90, 180, 270, 360, only we're in radians, so 0, pi halves, pi, 3 pi halves, or 2 pi. And so the quadrantal angle, I'm looking for where am I going to get a y value that's 0? Because when you're on the unit circle, the y values are the sine of that particular angle. So we have it at 0, the y value is 0, and at pi. And so we have the sine of 0 radians is the y value there of the ordered pair, which is 0. And we have sine of pi radians is the y coordinate when you're on the unit circle, which is 0 there. And we're not going to include 2 pi because we did not include 2 pi in our interval back up here. It was less than 2 pi. It isn't that the sine of 2 pi isn't 0, it's just we're not including, we only want from 0 up to 2 pi, but not including for answers. So my two answers, and we're in radians, so don't put a degree, it's 0 radians or pi radians. Those are the two angles whose sine is 0. I'm going to leave number 4 for you. I'm going to look at number 5 and then leave it for you to do the rest. And we have here cosecant is a positive root 2. So cosecant of x is positive in what quadrants? Well, cosecant is the reciprocal of sine. Sine deals with y and r. So this is cosecant is r over y. And so it's where your y's are positive, which are quadrants 1 and 2. And then I need to get the angle, or angles where I'm going to get a root 2. And those are going to be your 45-degree reference angles. So it's going to be 45-degree reference angle here and 45-degree reference angle here. Remember that root 2 over 2 came from 1 over root 2, and it's just the rationalization of it. And when you are going to need the reciprocal, it's easier to think about it as 1 over root 2 rather than the other values. And so I have cosecant of pi fourths is going to be r over y, which is 1 over, and if I use the 1 over root 2, it works out really nice because then you just multiply by root 2 over 1 and you get root 2 and you don't have to do a lot of rationalizing. And then we also have 3 pi fourths, which is r over y, which is 1 again. At 3 pi fourths, the y value was 1 over root 2 before rationalizing, which becomes root 2. So your angles that satisfy this equation, which are your solutions, are pi fourths and 3 pi fourths. So that's the work I want to see on all these, exactly the way I've been doing those 4. So continue with that on the rest of the worksheet.